All right, so the very first thing I'm going to do here is take our distribution of the probability of different numbers of thefts and turn it into a standard normal distribution. So here, I'll just write this in a slightly different way, but it'll be the same information. We have a mean of 65 and a standard deviation of 15. So here are 1, 2, and 3 standard deviation markers are going to go out on either side of 65 in the same way that we had in the last one. So 80, 95, 110, and then 50, 35, and 20. So each of these are standard deviation jumps away from the mean. And again, this is number of thefts. We're going to convert that to a standard normal distribution. In other words, a normal distribution in which all of the different units are z-scores. So everything is just being counted in z-scores. It's this easy. Our mean is equal to 1. Our mean is equal to 0. Our standard deviation is equal to 1. So our mean is going to be 0. And as we move out from the mean in standard deviation jumps, we're just going to be counting in 1, 2, and 3, and then -1, -2, and -3. And our unit at the bottom here is going to be z-scores. So no calculations required in moving from a normal distribution with some kind of units, whatever they are, to a standard normal distribution where all of the units are z-scores. And again, a really important point here is that nothing has changed about this graph, moving from here to here, except the units. So it's like going from feet to inches. We're counting in number of thefts here, and we're counting in z-scores here. But everything else, all the other properties of the graph, are exactly the same. All right, so how to use this to find a probability? So I'm going to use the example that I mentioned before. What's the probability that between 65 and 100 items will be stolen? So I'm going to start out by drawing this in a picture. And I recommend doing this anytime you have one of these problems. Think about where the different lines are going to fall on the graph. So our mean is 65, and we want to know the probability that between 65 and 100 items will be stolen. So you can draw it out like this. And if you think back to the properties of the normal distribution and the area under the curve being 1, what we really need to find is the area between these two values, because the area is going to equal the probability of getting an outcome that's between these two values. So our first step is going to be to convert any relevant values here into z-scores. And again, we're doing that because we want to find the area between these two values, because we know that that area will be equal to the probability of getting an outcome that's between 65 and 100. So we're going to convert these things to z-scores. We can start with 65 thefts. 65, as you know, is the mean. So just based on this, we should know that we have a z-score of 0. But I'll actually plug the values in here to reinforce this some more. So our z-score equation is going to be equal to this. Z is equal to our value minus our mean divided by our standard deviation. In this case, our value is 65. So we're looking for the z-score for 65. And again, I'll write out number of thefts here. So we're going to plug in 65 for our value, we'll plug in 65 for our mean, and we'll plug in 15 for our standard deviation. Well, 65 minus 65 is equal to 0, so this whole thing comes out to 0. And that's what we want. So we should have a z-score of 0 for our mean of 65. 100 is one of the same examples as I used on the last slide, so I'll just write this out here. The z-score for 100 thefts is going to be equal to 100 minus 65 over 15. So x minus mu over sigma. And this comes out to 2.33. So we have our z-scores for these values now. The next thing we're going to do is use a standard normal distribution and these z-scores to find the area under the curve. So I'm going to redraw this now with our standard normal distribution. So our units are z-scores. We have the same curve, it's the same shape, all the properties are the same, the only thing that have changed are the units. So our mean now is going to be equal to 0. And our value of 100 thefts is going to be equal to 2.33. And I'll shade this in as well. So we have the exact same graph here with the exact same area shaded in. The only thing that's changed are our z-scores. And here's where we're going to bring in something called the z-table. And this is included as a PDF in the folder for this week. And what the z-table shows you is the exact probability that falls between the mean and some z-score on a standard normal distribution. So I just want to hold up these pictures side by side here. We're looking for the probability or the area that falls between our mean, or a z-score of 0, and a z-score of 2.33 on a standard normal distribution. This handy table here tells you the exact area, or probability, that falls under the curve between 0, or your mean, and some z-score. And as it says here, it presents the area between the mean and the z-score. And then you can use this table to find that area. Again, as I mentioned before, all of these areas have already been calculated by people way smarter than me. And now they're just listed out in a table for us to use. So this is a reference, and you don't actually have to do any calculations in order to find the areas. You just need to look up the z-score that you're looking for. So in our example here, the z-score that we're interested in is 2.33. And here's how you read this table. You take the first value in your z-score, and the second value. So your 2 here and your first 3 here. And you find them in the column going down. So our z-score of interest is 2.33, so we're going to look at the 2 and the point and the 3 and find that right here. So here we've found 2.3 on our z-table. To find the actual area, we're now going to look at the last digit here in our z-score, which is a 3, and we're going to find it in this row going out here. So here's a 3. And on this last one, as you can see, there's a 0 and a 0 for the first 3 digits here. So this is just telling you, after you have 2.3, what do you have to add to get to the z-score that you're looking for? So we want 2.33. We're looking at 2.33. And then we're just going to see where these things meet. So we're going to go out here. We're going to go down here. And we're going to find that they meet at this box here. And the number in here, 0.4901, is the area that we're looking for. So again, we're just using that z-score that we calculated. We're using it as a reference on this table to see where we're looking on the table. So 2.33, we got our 2, our point, and our 3 in this column going down. We have our 0.03 in the row going out to the right, and we're looking to see where they meet. So this value of 0.4901 that I put a box around is equal to the area that we're looking for. So I'll write that here. And again, this table shows you the area that's shaded in here, which is analogous to the area that's shaded in here. So I'm going to put away the z-table for the moment, but that's all I used it for. I used it to find the area that corresponds to our mean and our z-score of interest. So thanks to the z-table, we know that we have an area here of 0.4901. Because our standard normal distribution and our other normal distribution are exactly the same in everything but the units, we don't have to do anything else in order to say that our area here is also equal to 0.4901. So it's the same exact graph, same exact shape, same exact everything except the units. So knowing that this area here is equal to 0.4901 means that we also know that this area here is equal to 0.4901. So we have an answer to our question. We wanted to know the probability that between 65 and 100 items would be stolen. We knew that that probability would be equal to the area under the curve between 65 and 100. So since we were able to find the area on the standard normal distribution and say it's equal to the area on the regular normal distribution, this area here is equal to our probability. So we can say that we have a probability of 0.4901, again equal to the area under the curve between 65 and 100, which we just found using our standard normal distribution and our z-table. That's our probability, which means we can say that there is a 49.01% chance that between 65 and 100 items would be stolen. And that's the answer to our question. I'll go through another couple examples of this, as well as how to find areas that don't include the mean here. But the basic steps are always going to be the same. You write out what you're looking for with the units of interest. So here we're interested in between 65 and 100. Figure out what shaded area you're looking for. Then convert everything to z-scores and find out the area under the curve using the standard normal distribution. The area under the curve that you found for the standard normal distribution will be equal to the area that you were originally looking for in your normal distribution with other units. All right, so I'm going to go through another couple examples here of different types of areas that you might find. So, for example, you might want to find an area that's going in the negative direction. So, let's say, for example, that we want to know the probability that between 60 and 65 items will be stolen. Well, I'm going to write out what I got here. So 65 is still our mean. 60 is less than 65, so we're putting a line in the negative direction. And we know that the probability that we're looking for is going to be equal to the shaded area under the curve in between these two values. So now I'm going to follow the same steps as I did before. First step, convert to z-scores. And these are the same numbers as I used before in the last example. So we know that for 65 thefts, z is equal to 0. So I'm not going to go through that before, but that's the same thing that I have on this page here, where you're subtracting 65 from 65 and dividing by 15. For 60 thefts, we're going to plug everything into the equation again. And here we have 60 minus 65 divided by 15. So x minus mu over sigma. And this is the same example that I showed in the how to calculate a z-score part of this lecture. So here we have negative 5 over 15, and this comes out to negative 0.33. So with z-scores now we can draw this as a standard normal distribution. Our mean is equal to 0. Our standard deviation is equal to 1. And we know that this value of interest has a z-score of negative 0.33. This means that we can redraw the graph like this. And again, it's the same exact graph in every single way. The only difference is that these units are number of thefts, and these units are z-scores. So now what we want to do is find the area in between the mean and this value here. So I'm going to come back to my document camera here. Sorry, not document camera, my z-table. And as you can see here, the z-table shows you the area between the mean and some z-score. But look, it's going in the positive direction. Does that mean we're stuck? No, it does not. And so even though here we're looking at the area between the mean and a negative score, we can still use the z-table. The reason for this is that this is a completely symmetrical graph. This means that the area between 0 and a z-score is exactly equal to the area between 0 and a negative z-score. So when you have a case like this, you can essentially just ignore that negative sign. So here we're going to be looking at z equals 0.33 on the z-table. So we're taking our z-score here. We're just going to ignore the negative sign because we know that if it was on the positive side over here, it would be the exact same area. So when you have a negative z-score, you're just going to ignore that sign and find the area between 0 and the positive version of that score. So again, for how to use the z-table, we look at our first two digits here, which are 0.3, to find out how far we're going down in this column. Here we have 0.3. We'll look at our last digit, which is a 3, to find out how far over we're going. So we're back to 0.03 over here. And now we're just going to figure out where these things meet. So here we have an area of 0.1293 for a z-score of 0.33. So coming back over here, we can say that this area that we were looking for is equal to 0.1293. Again, we have the same graph here as we did for the one that's counting in thefts, so we can also say that the area between under the curve between 60 and 65 thefts is equal to 0.1293. Same thing on both graphs, just the units are different. And now we have an answer to our question. So we said that we'd find our answer by figuring out what this area is, and our area is 0.1293. So we can say that there is a probability of 0.1293 that between 60 and 65 items will be stolen. Or in other words, there is a 12.93% chance that between 60 and 65 items will be stolen. And so you can also do this for different combinations of area on these graphs. And I'm going to go through one more example here where it's not going to include the mean as a value. So I'll just go to another page so it doesn't get too crowded. So let's say we want to find the probability that between $60 and $75 items will be stolen. So first step is going to be to draw this out. We have our mean at 65, so we have mean is 65, standard deviation is 15. We want to know the probability that between 60 and 75 items will be stolen, so slightly different set of numbers. And this means that we're interested in the area under the curve between 60 and 75. So now we have area on either side of the mean. Step 1, find z-scores. So here our numbers of interest are 60 and 75. So 60 is what I just did on the last one. Our z-score is going to be equal to, again, x minus mu over sigma, which comes out to 60 minus 65 over 15. And this is negative 0.33. For 75, we have z is x minus mu over sigma, so we have 75 for our x. Sorry, there's an equal sign there. So z is equal to 75 minus 65 over 15. And if you do this math out, you're going to get a value of 0.67. And for these, if you're using the z table in particular, it's generally helpful to round up to 2 digits, since that's how far out these are graded in the table. So we have 2 z-scores here. Now we can fill everything in our standard normal distribution, where our mean is 0 and our standard deviation is 1. So we have one line at negative 0.33 and one line at 0.67. And again, these are z-scores. So this tells you that this line is 0.67 standard deviations out from the mean going in the positive direction. This line is negative 0.33 standard deviations away from the mean going in the negative direction. And here, we want to find the area under the curve for these two values. Well, let's take a look at our z-table again. We only have one side shaded. So this particular table will only ever tell you the area under the curve between 0 and this value, and a value of z going in the positive direction. But, as I said before, you can think of this graph as a shape with an area. So what we're going to do is we're going to just figure out how to carve this thing up into shapes that correspond to what we're looking for. And in particular, I've already shaded the lines going in a different direction. So you can think of this as 2 different shapes, both of which we can find on the z-table. So here's our first shape, which is the area between the mean and a z-score of 0.67. We can also find this shape here, which is the area between the mean and a z-score of negative 0.33. And if we can find both those areas, we can add them together to get the total area under the curve for these shapes. So our first area here is going to be given by the area between 0 and a z-score of negative 0.33. So we already found this one on the last example here. As you can see, we're at 0 and negative 0.33, 0 and negative 0.33, and we're looking at this shaded area here, which corresponds to the shaded area here. So we already know that our first area is equal to 0.1293. But just as a quick refresher, we found that by looking at a z-score of 0.33 on the table. So again, if you're going in the negative direction, you can ignore that negative sign and then find your z-score for 0.33, which we went out to 0.3 and then 3 over here to get an area of 0.1293 between 0 and a z-score of 0.33. Because it's a symmetrical graph, this area is exactly equal to this area, so we were able to say that this total area here between 0 and negative 0.33 is equal to 0.1293. The next step we need to do is to find the area between 0 and a z-score of 0.67. So here we're going to say z is equal to 0.67, and look at our first 2 digits first and then our last digit. So our first 2 digits are 0.6, that means we're going to go down to 0.6 here. And our last digit is 7, which means we're going to go all the way out to 7 over here. And then we're going to figure out where these things meet up. So we've got 0.6 and 0.7 is this column. This means that the area under the curve for 0.67 is going to be equal to 0.2486. So I'll write that in here. So now we have areas that correspond to both of these different sections of the graph. We have an area of 0.1293 between 0 and negative 0.33, And again, that's what we found in the last example when we were only looking at the area between 0 and negative 0.33. We also have an area of 0.2486 between 0 and 0.67. So to find the total area here, we're just going to add these two together. So we want to find the area in here and the area in here all together. So I'll say this gives us an area of 0.1293, and this gives us an area of 0.2486. So the total area is equal to 0.1293 plus 0.2486. So in other words, that's what gives us this total chunk of the graph. And if you add those two things together, you should get .3779 as your total area. So all of that tells us that this total area under the curve on the standardized z-score is equal to 0.3779. Because our standard normal distribution is the same as our other normal distribution, we can also say that the total area under the curve here is equal to 0.3779. And that can be broken up into these two halves also. If our total area under the curve between 60 and 75 thefts is equal to 0.3379, we have our probability. So our probability is equal to 0.3779, which again is equal to this area under the curve that's shaded here. And we can say that there is a 37.79% chance that between 60 and 75 items will be stolen. And so that's as far into using z-scores to find probabilities as we're going to go here. And you can also find different probabilities. So for example, you could find the probability of getting a z-score between two negative values or between two positive values, but we're not going to spend that much time doing this. So the takeaway here, though, is that you can standardize your normal distribution and then use the z-table to find the area under the curve for different values. And I'm not going to go back to the PowerPoint, so from here on I'll just say this ends our lecture and have a great week.